In this video, we're going to start talking about units. Remember, we have three parts to all of our numbers: our magnitude, our amount of uncertainty, which we talked about in our last video, right? Our number of significant digits are going to define that, and then a unit. So there's three common systems of units, two of which we'll use in this class, one of which you probably use in everyday life, but we won't use it much in this class. So there's three systems of units. So the Imperial System, which it goes by a lot of different names. It's kind of an older name, honestly. US Standard System, there's a few of them, but it's the one that we're used to. So temperature in degrees Fahrenheit, cups, pounds, all of that sort of thing, miles, inches. We'll use it in this chapter just as a way to convert between stuff that we're used to and the metric system, but after this chapter, we're really not going to use that system at all. The metric system, and then the SI system. SI actually stands for the International System of Units, and this is actually our official system of units in chemistry, actually in science in general. And it is based on the metric system. So we still have, centi and milli and all of those sort of things in the SI system. It's just that it's based on 7 fundamental units. So there's 7 fundamental SI units. Your textbook calls them base units. I like to use the word fundamental instead of base, just because I'm going to use the word base when we're talking about the metric system, and I don't want it to be confusing. But just note that the book, right, our online textbook, calls these base units. Other than right now, I'm not going to use that term to refer to them, so I am going to consider them, we're going to call them fundamental. Again, just so it doesn't get confusing. So we're going to make a little table here where we have the quantity that we're measuring, the name of the unit, and then the abbreviation. So our first one is going to be mass. And we talked about mass in part 1 of chapter 1. Remember, we said mass was the amount of matter in an object. And then our official unit for mass is actually a kilogram. A lot of people get this one wrong on exams. They'll say a gram. A gram is, this is why I don't like to use the word base. A gram is the base unit in the metric system, but a kilogram is the official SI unit for mass. And then our abbreviation for kilogram is a lowercase k, lowercase g. Our next one, and these are in no particular order, they're just as I think of them. We can do length. Our SI unit for length is a meter, which is also the base unit in our metric system. Lowercase m is our unit. We could do time. Time is going to be a second. This one is actually the same in all of our systems. Lowercase s, please make sure that it's lowercase. We could do amount. And our unit for amount is going to be a mole, and we're going to talk in a lot of detail later about moles, but MOLE, and then its abbreviation is MOL. Be careful, I'm going to go down a little bit, not to get mass, right? Mass is the amount of matter in an object. So how much stuff is it made up of? Remember, matter was defined as anything that has mass or occupies space. 2 definitions that I've always found very unsatisfying, right? Mass is the amount of matter, but then matter is everything that has mass. It's just circular, sorry. But mass is the amount of matter in an object, so how much stuff is it made up of? Amount is how much of it do we have, right? What's the amount? how much do we have. Not how much stuff is it made up of, but how much of it do we have. And then not to be confused with volume. Volume is actually not a fundamental unit. We'll talk about volume when we talk about derived units, but volume is the amount of space something occupies. So just be really careful. It's very easy to get those three mixed up. So mass, how much stuff is it made up of? Amount, how much of it do we have? Volume, how much space does it take up? So just be careful on those. They're often kind of mixed up in our heads. It's really easy to do. Temperature. Our SI unit for temperature is going to be Kelvin. And then its abbreviation is a capital K. Our imperial system is degrees Fahrenheit, so degree sign and an F. Metric system, degrees Celsius, a degree sign and a Z. And Kelvin is just a K, no degree sign when you're writing it. So be careful for that, capital K. The last two we don't actually use a whole lot. You will use this one in 152, so electric current. And our unit for that is an ampere. And its abbreviation is a capital A. And then the last one I never really use other than to say that it's one of the fundamental units, but it's luminous intensity. Essentially how bright is something. And this one is a candela. And its abbreviation CD. So do know all seven of those, know the name of the unit and the abbreviation of the unit. So let's talk about the metric system next. If you don't already have some of these memorized, I do want you to learn them. You'll be using them throughout your science career, so it's important to know the relationship between them. So the ones that I'm going to go over are the ones that I'm asking you to memorize. If there's ones that aren't on the list that I'm about to give you, then you don't need to memorize them. I would provide them with a test or a quiz if you need them. But these, please do commit them to memory. So what I'm going to do is I'm going to kind of start just a little bit towards the top of the middle of the page here. And then anything that I write above it are units that make my base unit bigger. Anything I write below are going to be units that make my base unit smaller. We are going to cover more that are smaller than are bigger, and that's why I'm going to start slightly higher than center. So in here, I'm going to have my base unit. And it can really be anything. So examples, it could be a gram, we could have a meter, we could have a liter. We'll talk about liters here in a little bit. It's going to be a unit that we use for volume, one of our derived units. Mole, we could do seconds. It really doesn't matter. Honestly, you could even do inches if you want, and these prefixes would still work. Underneath these, I'm going to put the unit, or the abbreviation, so lowercase g, lowercase m. Liter is actually a capital L. Please, when you write it, make sure you capitalize it. MOL, and then S for a second. So again, things that I write above it are going to be things that make that base unit larger. So the first one we're going to do is kilo. And there are others. These are just the ones that, again, that I'm expecting you to know. So kilo is going to make it 1,000 times larger, or 10 to the third. And my abbreviation for kilo, let's actually write this a little differently. Let's do kilo. My abbreviation is a lowercase k, and then it's going to make it 10 to the third times larger. So you can put kilo in front of any of those base units, or others even, and it's going to make them that much bigger. So I'm going to just kind of make some notes down here. I would say that there's 1,000 or 10 to the third grams in one, and then I would put the lowercase k for kilo in front of the lowercase g for gram in 1,000 kilograms. There's 1,000 moles in 1 kilomole, right? there's 1,000 liters in 1 kiloliter. So anytime you put kilo in front of your base unit, it makes it 1,000 times bigger. The next one that we're going to do is mega. And mega is going to be a capital M, capital, and that's going to make it 1,000,000 times bigger. So 10 to the 6. So there's 1,000,000 meters in a megameter. There's 1,000,000 seconds in a megamole. And then one more, and that's giga. And that's a capital G. And then that's a billion. So 10 to the 9th. So 1 gigagram, right, is a billion, or 10 to the 9th grams. So these make it larger. Going down, we're going to include ones now that make it smaller, and the first one we're going to do is deci. Our abbreviation for deci is a lowercase d, and then this is going to make it 0.1 times smaller, or 10 to the negative 1. Centi, lowercase c, and that's going to be 10 to the negative 2, or 0.01. Milli, lowercase m, and that's 1,000th, so 10 to the negative 3rd. And it's the same system like we were doing up above, right? Anytime I put one of those in front of it, it's going to make it that time smaller. So there's 10 to the negative 2 grams in 1 centigram. There's 10 to the negative 3 liters in 1 milliliter. Again, please make your L's capital. There's 10 to the negative 1 moles in 1 decimole. We're going to do 2 more that are smaller. So nano, micro first. Micro. And we've run out of M's, so we used a capital M up here for mega. We used a lowercase m down here for milli, so we're actually going to pull up Greek, and we're going to use the Greek letter mu. So it's like a U, but it has this like tail that comes first, and that's going to be 1,000,000th, or 10 to the negative 6. Right, so there's 10 to the negative 6 meters in 1 micrometer. That's how we would write that. And then one more that I want us to memorize, and that's nano, lowercase n, and that's 1,000,000th, so 10 to the negative 9. So 10 to the negative 9 seconds in 1 nanosecond. That's incredibly fast. Do watch out for this. I do this all the time, and I'm probably not the only one, and honestly, I think you're probably going to start doing it too, is I don't really like negative exponents. So if we look at my examples over here, like it's harder for me to visualize it and kind of wrap my head around it. So if you take the unit, right, the quantity right from this table, then it goes with the base unit. So like this first one, I did centi. Let's use a different color here. I use centi. So the 10 to the negative 2 went with the base unit. Here I did milli, so the 10 to the negative 3rd went with the base unit. What I tend to do, and I think most instructors tend to do, is if you put the quantity with the prefixed unit, then you switch the sign on it. So if we look at this one, you could say that there's 1 liter in 10 to the 3rd, positive now, milliliters. Those would mean the same thing. And I tend to write them this way. So to me, it's easier to see that there's 1,000 milliliters in a liter than 1,000th. Like it's hard to wrap your head around 1,000th of a liter in a milliliter. I would say, if we look at this first one, that there is 1 gram in 10 to the positive 2, so 100 centigrams. So there's 100 centigrams in a gram. So again, if you want to use them straight off the table, that's fine, but then the quantity goes with the base unit. If you switch the sign, then it goes with the prefixed unit, right? Another one, if I look at this one, we could say that 1 second is a billion nanoseconds. So that's how I tend to write them. We're going to go through unit conversions next, and when we do that, I'm going to tend to use this form of them. So let's talk a little bit about derived units before we start unit conversions. So we just got done talking about our 7 fundamental units. All of our other units are based on those. They're derived. They're made up of combinations of our fundamental units. So derived units. And the first one I want to talk about is volume. So we already said that volume is the amount of space that an object or substance occupies. And our SI unit for it is actually a meter cubed. If you think about just a rectangular solid, determining the volume of that, you would take length times width times height. All of those are essentially lengths, right? The width is just the length from a different perspective as well as the height. Our SI unit for length is meters, so meters times meters times meters, or meters cubed. So that would be our SI unit. It's not a unit that we use very often for volume. The one that we usually use is a liter. And we've used a liter, we've mentioned it a couple times in this video. Our abbreviation is a capital L. And then kind of the conversion between a liter and length units is that 1 liter is equal to 1 decimeter cubed. So remember, deci is a tenth of a meter. So a decimeter times a decimeter times a decimeter would get me a liter. 1 decimeter cubed is the same as a liter. Liter is the unit that we're going to use most often. Actually, milliliters, we'll use smaller amounts than a liter. So 1,000th of a liter. Remember, there's 1,000 milliliters in 1 liter. But again, derived, because we're making it by taking essentially length times length times length. So not fundamental, but something we make from other units. Another one that we're going to see a lot is density. You're actually going to have a lab on density, so you'll talk in more detail there. But density is defined as how tightly the particles are packed together in a substance. So how tightly the particles are packed together. Generally, if I ask folks what is density, they'll tell me mass per volume, right? That's how you would have learned it in 130 or high school. And you're not wrong. It is calculated by taking the mass and dividing it by the volume. But what does that mean to us? What it tells us is how tightly those particles are packed together, right? Mass, remember, is the amount of matter in an object. So how much stuff is it made up of? Volume is the amount of space that it takes up. So if you have a lot of mass and a little bit of space, those particles are very tightly packed together. If you have a little bit of mass in a very large volume, then those particles are pretty spread out. So if you have a small density, the particles are not very close to each other in that substance. If you have a large density, it means that those particles are very close to each other. So how tightly are those particles packed, right? How much stuff is it made out of relative to the amount of space that it occupies? Our SI unit, again, one that we don't use very often. My SI unit for mass was a kilogram. My SI unit for volume we just did was a decimeter cubed. Common units of density for us. Generally grams per milliliter. And you're going to see that one if it's a volume, or sorry, if it's liquid most often, or grams per centimeter cubed. Oh, I'm going to go back up real quick. Back up here to volume. I do want you to know this conversion. 1 centimeter cubed is actually equal to 1 milliliter. They're the same. So if I had a density of 2.70 grams per milliliter, it's also 2.70 grams per centimeter cubed. Those are the same. So do know this conversion. It's one that I would like you to memorize. So cubic centimeter, sometimes called a cc. So a cc is a centimeter cubed or a cubic centimeter, however you want to say it. So if you've gotten shots before and they say they're going to give you 2 cc's, they're giving you 2 milliliters. It's the same thing. So again, know this. Know this conversion. You should be able to just, if you see centimeters cubed, just switch it out for milliliters very quickly. They're the same. It doesn't affect the number at all. So common units, this is generally if it's a liquid, it doesn't have to be. If it's solid and you're figuring out the volume by water displacement, and you will do that in lab, grams per milliliter are going to be your units. If you're measuring the solid using a ruler or a caliper, then you're going to have units of length, so that's what you're going to get. I'm just fixing this because it should be a lowercase c and it looked kind of big. Centimeters cubed. Sorry, my accuracy with my stylus here isn't always great. Of course, my handwriting leaves something to be desired. And then you can see grams per liter. This you'll generally see if it's a gas. And again, it doesn't have to be, but those are the common units that you're going to see for density. Lots of other derived units. A joule is a derived unit. Joule is our SI unit for energy, abbreviation J. Again, it is derived, and it is a kilogram meter squared per second squared. Area, a Newton, our unit for force, all of those. So lots of derived units, right? Only 7 fundamental units. All of our other units that we're going to encounter are derived. So volume, if you want to space something takes up. Density, how tightly my particles are packed together, right? Mass, how much matter is made up of relative to the amount of space it occupies. And then my SI unit for energy, do you know that one also? Oh, real quickly, I missed this. Mass versus weight. What's the difference? What do you guys think? Yeah, hopefully you said that weight is dependent on gravity. And if you didn't know that, that's okay, because now you do. So mass, again, the amount of matter that something occupies. Weight, this is the gravitational force, or due to the gravitational force. So if you're in a different gravity field, your weight is going to be different. So like my mass on Earth and on the moon are going to be the same. I'm going to be made up of the same amount of matter, whether I'm on Earth or I'm on the moon, but my weight is going to be different because gravity on the Earth is different than gravity on the moon. So we want to try to get in the habit of talking about mass. We can still weigh things. We don't mass them. We weigh them to determine the mass. So the balances in lab are actually calibrated to give us mass, but we are weighing them. But you're not determining the weight, you're determining the mass. It's kind of the habit we want to get into using. So in the next video, we'll do some unit conversions. So please start learning these because we are going to use them. So again, these ones on the table up here that I gave us are ones that you need to commit to memory. Oh, I never gave you this one, but these are our ones that are smaller. I guess as evidenced by our negative exponents.